Hello everyone. I hope you have good time for Easter and you're keeping well. So in continue of what I was explaining about system response, I have three more slides that I'm going to explain. Here we have one electrical circuit and we have a resistor which is in series with this capacitor and voltage V is applied on the circuit. So we want to look at the uh, differential equation as I explained before. So we know that the relationship between the voltage across the capacitor and the main voltage is that the capacitor starts to charge up to a maximum voltage, which in this case will be proportion to the main V, and then stays at that charge, and we will have current flowing up to that point, and then it will stop for a while. That's what we know from capacitor circuits. So, and you know that the rate of change of potential difference or the voltage we see across the capacitor with time, the change with time is the derivative of dVc over dt, and it is proportional to the difference in value between the Vc and the input voltage V. So the difference between these two voltage is proportional to the rate of change of the Vc. That's what we know. From another point of view, the way that I explained about charging up the capacitor, we know that we will have a graph like this. So it is exponential graph again, and it will start to charge up to maximum this point, which is the V. And now, if you want to understand how this graph can be described, you're looking at this equation here. So Vc is equal to V in 1 minus e power 1t over Rc, which R is the amount of resistance and C is the capacitor C. And if I want to put that black box on top of everything and look at what is the input and what is the output of the system, obviously we know that this circuit won't work if we don't put the input V. So the input will be the voltage that apply, and the output will be the behavior, what we are getting across the C. So the output will be voltage of the capacitor. That is one good example, very basic, but explaining how a typical RC circuit can be analyzed from a differential equation point of view. Now, another example we have is when we have a thermometer and we put it in hot liquid. If you guys remember from previous semester and also this semester, we talked about this typical example many times. Depending on what room temperature was before, so we are reading from up or from down, so we will have some changes. Whatever the thermometer is reading, we are calling it theta, and then the theta h will be the temperature of that hot liquid. So again, we are looking at one reading parameter and another one which is the maximum or another milestone temperature which we want to achieve. Is very similar to that RC circuit here in different scenario. So two questions. What is the differential equation describing how the thermometer temperature changes with time? The answer for that is we know that the rate of change, the reading theta of thermometer, d theta dt, is proportional to theta h minus theta, the difference between the reading and the maximum temperature, and this k is the constant. So this is what we know about the differential equation describing how this thermometer is working. Another question, the theta graph, the equation of the graph theta with time. So I'm not drawing it, but it will be very similar to what we are seeing from RC circuit. But we are reaching to the point to know that all first order systems can follow a generic form. In this case, theta is equal to theta h 1 minus e power minus kt. So we have that constant k here again. Now, from these two examples, we can have a generic form for first order equations. For all first order equations, we can come to this point to have this generic form. So we have this subtraction, and then we can rewrite it in another form where we have constants. A0, A1, and B0 are constants, and theta I is the input function to the system, and theta O is the output. This is O, not 0 for output. And the rate at change the output is changing with time is d theta O over dt. Now, here is a good chance to talk about what kinds of inputs we can have. So far, we were talking about step inputs. So, a step input is when we have nothing, and then at some point, we start to have a constant input. That is called a step motor. And then impulse input is another kind of input where at very short period of time, we have sudden input to the system. And the ramp input, as you see, is a linear and continuously increasing type of input. And then we have sinusoidal signal input, as you can see in this picture. I hope you understand it, and if you have any question, feel free to send me your questions by email. Thank you.